So graphing or tracing a line, method one that we're going to look at is a table of values. What a table of values is you get a bunch of points, and you get those points with a table of values by choosing values of x and then using your equation to find the values of y. And once you have your points, take out a ruler, join your points, and you'll have a straight line. So what does this look like? If we want to graph the line y equals x, in a table of values, we always put our x, because it's our independent variable, first, and our y second, because it's our dependent variable. So you choose at least 3 values of x. It's often good to choose a negative value. 0 is a nice number to choose because that will always be your y-intercept. And a positive value. So I'll try -1, 0, and 1. Now, in this equation, y is equal to x. So when x is -1, y is going to be -1. When x is 0, y is going to be 0. And when x is 1, y is going to be 1. Now, these become points. In your table of values, this represents the point -1, 1. This represents the point 0, 0. And this represents the point 1, 1. So we can go to our graph and say, okay, if I plot -1, 1, 0, 0, and 1, 1, well, they make a nice straight line. I join the points, I extend it. We always put arrowheads on the end of our line to indicate that that line continues on forever. And so we just graphed this line. Second equation, y equals 2x. So we choose any values of x we'd like. Usually, like I said, pick a negative value, pick 0, pick a positive value. What negative value do you want to use this time? -3. Pick 0. What positive value do you want to use? 5. So it really doesn't matter. And if you would like, if you don't feel that 3 points are enough, you can always do more. And I'll show you an example of sometime maybe this happens to you and you might want to do some more points. Okay? We'll add it after this one. But for this one, y equals 2x. If I plug in -3 for x, 2 times -3 is -6. So I have the point -3, -6. I plug in 0, I get 0. So I have the point 0, 0. Plug in 5 for x. 2 times 5 is 10, so y is equal to 10. So label your points, take out your ruler, draw the line through those points, and put arrowheads on the end. Now I'm going to show you an example of where you might want to do more than 3 points, okay? Because this could happen to you. So what I'm going to do is, everybody got this down? I'm going to erase this. Don't add this into your notes. I'm going to make a new equation. All right, and I'm going to put in -2. Let's go -2, 0, and 3. Okay? So x plus 1 is what you have, so you're plugging in numbers, -2 plus 1, -3, 0 plus 1, 1, 3 plus 1, 4. You go to graph it, -2, -3, 0, comma 1, and 3, comma 4. And you go to take out your ruler, and they don't match up. Yeah, I made a mistake, I know. But I'm just saying that sometimes you might not realize you made a mistake while doing it, and you plot your points and they don't line up in a straight line. And you're like, ooh, I don't know which point is wrong. You could A, check your mental math on all three of them and realize, yes, you made a mistake on that first one. Or B, add another point. So if I added another point, say I put in 1, it's a number I haven't done yet. 1 plus 1 is 2, and I'm like, oh, something must have went wrong with this point, because now I have 3 that end up nice in a line. Maybe I should check that again. What is -2 plus 1? -1. Oh, that's where it was. That makes more sense. And now I can join. Now, technically, to use a table of values, you really only need 2 points to ensure that you'll get a straight line, right? But if you make one mistake on one of those 2 points and join them, then your whole line is going to be wrong. So we generally say, let's do 3 points, because if you make a mistake in 3 points, this is exactly what's going to happen. It's not going to line up. That's going to tell you, okay, well, maybe I should do another point. And if there's like, they all don't line up, then you've got major issues happening, and that might mean just want to start again. But in this case, once I did third point, I realized, oh, 3 of them are in a row. I should check my math on that first one. I realized -2 plus 1 is -1. And I tried to do a typical mistake where if you weren't quite paying attention, you might do that, right? You're like, oh, 2 plus 1 is 3. Oh, I'm dealing with a negative. I'll just put a negative in front. Right? Some of those mental math things that you go, oh yeah, I've done that before. I've done silly mistakes like that. Sometimes we'll deal with fractions. And when dealing with fractions, again, you can choose any values you want. But when dealing with a fraction, there are some choices that end up with nicer numbers than others. For example, if I plug in an odd number, I'm going to get a decimal. But if I plug in an even number, I'm going to get a whole number. So in this case, when choosing my 3 values, I might notice that and say, my x has to get divided by 2. That's what that 1/2 in front does. It divides it by 2. Why don't I choose even numbers so that it works out nice? -4 divided by 2 is -2. 0 divided by 2 is still 0. And 2 divided by 2 is 1. -4, -2, 0, 0, 2, comma 1. They all line up nice in a straight line. Oh. If this was my graph on a test, quiz, or exam, I would lose a half a mark because I haven't labeled anything. Okay? You may assume, and often students do this, they assume that every time you have a grid mark, that means 1, but it doesn't mean it unless you label your points. So you need to label it somehow to indicate what your scale is along your x-axis and what your scale is along your y-axis. Just having the points here and saying, I think it's obvious, yes, I agree it's obvious, but according to the marking guides all the way up to grade 12, that will be a half a mark deduction for not labeling your scale. How did that Oh, I skipped something. This was, okay. Here. Find the slopes in examples 1 to 3. So let's go back. And I guess in this one I have to erase what we had. Example 1. What's our slope in this one? Remember that slope is rise over run. To go from one point, we go up 1 over 1. So your slope will be 1 over 1, which is just 1. In the second one, which I have to regraph here, we had this point, we had, I don't know, this point, this point, this point. Take any 2 points that you had. Say I chose those 2 points. If I chose those 2 points, my rise is 4, my run is 2. Remember that things that go up from left and right have a positive slope. 4 over 2 simplifies to be 2. And finally, in our last one, if I choose this point and this point, I go up 2 over 4. Slope is rise over run. This reduces to 1/2. In each of our equations, the slope shows up in the equation. Now, we've already talked about y equals mx plus b. Can you see that all of these equations are in that form? We have a number in front of x. We have y by itself. So the number in front of x is our slope. And there's no number written afterwards. What does that mean your b value is in each of these? 0. And the b value stood for the y-intercept. Can you see that in each of our examples, we had a y-intercept of 0? This was y equals 2x plus 0, so the slope is 2. This is y equals 1x plus 0, so the slope is 1. Right? So the coefficient in front of x is the slope only when it's in y equals form. Okay? The coefficient in front of x is the slope only when it's in y equals form. Because if I had 2y equals 4x plus 8, my slope wouldn't be 4. I don't have y by itself. But if I divided everything by 2, this equation would become 2x plus 4. Then I could say my slope is 2, my y-intercept is 4. So we have to rearrange it so y is by itself in order for the coefficient to be equal to the slope. Some more that we can do with our table of values. Again, x goes first, y goes second. Choose some negative values, choose 0, choose a positive value. Right? I don't think we've used -3 yet. Might be getting jealous out there, so just to keep things calm. 0 again. Positive number we haven't used for a while. Don't say 800 or something. It's going to be way off the graph. 3? Also 3? Okay. So plug in -3. -3 times -3 is 9. 9 plus 1 will be 10. Whew, that almost went off our graph. 0 times -3 is 0, plus 1 will be 1. 3 times -3 is -9, plus 1, -8. So we have the point -3, 10. We have the point 0, 1. And we have the point 3, -8. Wow. Put arrowheads on the end of your graph. This has a negative slope. We could say that the slope is -3 just using the coefficient in front of x, because y is by itself. We could also find the slope by saying, here we go down 9 and over 3 to get from one point to the other. And when you have the slope, you could just say, oh, I could go down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. And you could get a whole bunch more points on your graph using your slope, recognizing that pattern. Notice that our y-intercept is 1, and that matches with y equals mx plus b. All right. When you have coefficients in front of both x and y, there's a possibility that there might be some fractions. In this case, I don't think choosing any values, I think it's going to work out all right. But let's see what happens. Choose a negative value. Choose 0. Choose a positive value. In this equation, we can't look at it and say, I know what the slope is. I know what the y-intercept is, because it's not in y equals mx plus b form. And even when plugging things in, we're going to have to do a little bit of math. Because the way the equation is right now, when I plug in -1 for x, that would mean I'd have 6 times -1 plus 3y equals 9. Well, I still have to solve for y. 6 times -1 is -6. What would you do next to get y by itself? Add 6 to both sides. Good. Right? Whenever we have like terms and they're on opposite sides of an equation, you move them to the same side so you can combine them. So there we go. 3y equals 15. And then to get y, divide by 3, and we get y is equal to 5. Whew, that was more work than normal. Plug in 0. 0 should be a little bit easier. Okay, I'm going to erase this and do the same work, plug in 0. 6 times 0 plus 3y equals 9. Well, that would just be 3y is equal to 9. Divide by 3. And y is equal to 3. And so compared to the other ones, this one we have to actually do some calculations. The other ones you could plug values in and do basically mental math to figure it out. For this one, we have to sort of work a little bit to get our values. And finally, when x is equal to 1, that is the smallest one, there we go, we would have 6 times 1 plus 3y equals 9. There's our like terms, 9 and 6. Get them to the same side, so I'll subtract 6 on both sides. Divide by 3, and I get 1, 1. So because we're doing more calculations, this could possibly be one when you plot your points. You might have made a mental math error and they're not in a straight line, but I have -1, 5, 0, 3, and 1, 1. They appear to be in a straight line, so we can graph that line. Can you see that when we solved for y, we got y by itself, right? The question is, if we started with this equation like this, could you get y by itself? What would you have to do? We could start by subtracting the 6x on both sides. That would just give me 3y equals. Now, when writing this side, can I put 9 and negative 6x together? No, those aren't like terms. Are you okay that I'm going to write the negative 6x first? Because I'm going to, in the end, try to get it to look like y equals mx plus b. You can write it y equals b plus mx if you want, but we sort of get used to writing the slope and the x first and then the b at the end. So we'll do that as well. And then divide by 3. Now, when you divide this side by 3, that's easy. That becomes just y. When you divide this entire side by 3, that's like dividing each individual thing by 3. So we would get negative 2x plus 3. Can you see that our line has a y-intercept of 3? That seems to match that equation. Can you see that our line has a slope of negative 2? That also seems to match with that equation. Would it have been easier to do your table of values with this form of the equation rather than what we had to start with? Maybe. So maybe it would be something you would like to do first. Rearrange your equation for your table of values. You have that option. You can either get your table of values first, or you can rearrange things and then get your table of values afterwards. All right, I'd like you to try this one on your own, and I'll put the answers up in a second. All right, let's check how you did. Everybody plugged in 0, right? Did you get negative 1? For negative numbers, negative 1, did people plug in negative 1 and get negative 3? Did anybody plug in negative 2 and get negative 5? Did anybody plug any other negative numbers in? No? Those were the only ones? How about positive numbers? People plug in 1 and then get, what do you get? Plug in 1 comma 1? Yes? And 2 comma 3? Anybody plug in any other numbers? 3 comma 5. Perfect. So when we plot these points, we have 0, negative 1, negative 1, negative 3, negative 2, negative 5, 1 comma 1, 2 comma 3, 3 comma 5. Did you draw your line through those points and have an arrowhead? Did anybody rearrange it first to get y equals 2x minus 1? Good. So in this part, we can tell that our slope is equal to 2 and our y-intercept is equal to negative 1. Do you know why they use b for y-intercept? It's not because a y looks like a b. Technically, when writing this equation, some textbooks will have ax plus b, because when you're listing coefficients of variables, you start with the letter a and then go to the letter b. Okay? Since the a is important and it's a slope, they change the letter of a to m. But you will still see some textbooks call the equation y equals ax plus b. If you go to your calculator, I think, has ax plus b built in to it somewhere. Okay? And then next year or next semester, you're going to learn about parabolas. And they are ax squared plus bx plus c. Just using the letters in order. So that's why the y-intercept has its own letter b, and it never got changed to a special letter because there is no special letter for the y-intercept. Okay, so a little bit of planning.